welcome back. We're going to pick up, we were just talking about Ptolemy and his views, geocentric, and we're picking up now much further into the future, a whole lot closer to when we're alive, unless you're watching this magically very, very, very far off in the future. But Nicholas Copernicus was a Polish astronomer and doctor and a whole bunch of other things. I think he was a monk. But also, Nicholas Copernicus is probably somebody that you've heard of before. But huge jump forward in time. Largely because Ptolemy's system, as weird as it seems to us, Ptolemy's system worked. It did a good job of predicting where will we find things in the night sky on a particular day and time. But Copernicus proposed a heliocentric model of the universe. Now, we know that the word geocentric is Earth-centered, so if only we could sort out what this helio refers to, then we would know what this word means. Now, one word that this has in common, the word is helium. You might have heard of helium before. But helio is a reference to the Greek sun god Helios. And amazingly enough, helium is mostly in the universe produced in stars, like our sun. So helio is a reference to Helios, the Greek sun god. So heliocentric means sun-centered, just as geocentric means earth-centered. So Copernicus proposes this radical idea that the Earth is not at the center of the universe. I said that wrong, that the Earth is not at the center of the universe, but the sun is. And this is a pretty radical idea at the time. Now, Ptolemy's model had lasted so long, like I said, because it worked well. But Copernicus is saying that, yeah, it worked, but conceptually there are some significant problems with it. A lot of Copernicus's work was based on the mathematical work of Persian and Syrian astronomers from a couple hundred years ago, and a couple hundred years ago relative to Copernicus, not us. And so these aren't all original ideas of his, but he's combining them in new ways, certainly not familiar concepts to most people at the time. He wasn't the first and only person either to suggest a heliocentric universe, but he put together a book that started making the case for it. Now, Copernicus still used circular orbits, still had celestial spheres, although one difference is that they weren't all concentric celestial spheres. And if you think about the word concentric, again, trying to develop some skills here, concentric, con is with center, concentric circles are circles that are all centered around the same point. He still needed epicycles to get accurate predictions, but there were some simplifications. He fixed some problems by switching over to a heliocentric universe, fixed a couple of problems, like how Mars would sometimes end up coming closer, and there were some problems that this heliocentric version was able to clean up a little bit. But a major problem here is that Copernicus doesn't have any evidence of what he's suggesting, and it's a pretty radical idea. Radical ideas without much evidence generally don't go very far. Copernicus published his book, De Revolutionibus Orbium Coelestium, that's in Latin, that's worth noticing, in 1543, which is also the year that he died. De Revolutionibus Orbium Coelestium, from Latin, really roughly translates as like on the revolutions of celestial orbs. So that sounds like orbits. He had done this work a couple of decades before. Probably at least like 30 years he just sat on this, not literally, and was afraid to publish it. A lot of thinking is that he was afraid of the critical response, but also being very deeply Catholic, like a lot of Europeans at the time were, he was very, very, very Catholic. And the Catholic Church at the time, the Roman Catholic Church, was not really receptive to this idea. And so there are some people who think that he was also afraid of upsetting members of the church in publishing this, because the Roman Catholic Church was very much tied to geocentrism, where the whole universe exists for us. So that may or may not have. Some people think so, but we're not sure that we have enough evidence to say, like, yes, he definitely held off on publishing it. But fortunately for us, eventually, when he was 70 years old, he agreed finally to publish it. So, good for us. Except, well, nobody really paid any attention to Copernicus. He didn't get a whole lot of attention because, well, he didn't have evidence. Until Galileo comes along. You've, of course, heard of Galileo before. And if you check this time period, we're fast-forwarding a couple of decades now. Things that Galileo did. First of all, he invented a new type of telescope. And with that telescope, he observed 4 moons orbiting Jupiter. We still call those 4 the Galilean moons of Jupiter. There are a lot more than 4 moons of Jupiter, but those are 4 big ones. They're all really cool and interesting. I'll tell you about them later, I hope. But this is a big deal because we could now clearly see here is something that's orbiting something that isn't Earth. And so now we can definitely see that it's possible for Earth not to be at the center of everything. He also observed with this telescope phases of Venus, just like we see phases of the moon. Galileo saw phases of Venus which just can't happen in a geocentric system. And so now we have evidence, 1, of things can orbit something other than the Earth, 2, of there is a real problem. We have observations that directly conflict with geocentric universe models. And so now we're finally starting to build some evidence, thanks to Galileo, that can support Copernicus's ideas. And when we've got radical ideas, we need real evidence. And so this is what starts to turn the tide for people to start buying into this idea. And Galileo was a rebel. Galileo wrote a book about the Copernican model, and he published it in Italian, not in Latin. And this was a major problem for a lot of people, because the only people who would get to learn Latin were the elites of society, and ordinary people like you and me. We're not fancy enough to get the kind of education that teaches us Latin. And this was kind of a way that in Europe all the science was done in Latin. If you look at Newton's writing, it was done in Latin, although Newton comes after Galileo. If you look at, and Newton was English. If you look at Copernicus's writing, he was Polish, but he wrote in Latin. All the science was being done in Latin. But Galileo wrote in Italian. And so ordinary people like you and me who aren't fancy enough to learn Latin, now we have access to scientific knowledge. And so this upsets people who want to restrict access, because after all, if I'm fancy and, well, then I get the good jobs, and then my kids get the good education, they get to learn Latin, they get the good jobs. Europe, of course, has a long, ugly history of pretty strong class divisions, and that in science was part of that. But by publishing in Italian, ordinary people can access this book. And so Galileo angered a lot of people for that reason, but he also angered a lot of people because, well, he wasn't the most polite he could have been in the way he wrote this book. Galileo and the Pope actually had been on really good terms. They really liked each other. Galileo, of course, was Catholic. He was Italian. And in the 1600s, everybody in Italy was Catholic. But what Galileo did was, the way that he wrote this book was written as kind of like a dialogue between 2 people debating geocentric ideas versus heliocentric ideas. And the geocentric arguer comes across in this book as an idiot. And the heliocentric arguer comes off as like our hero, who's always got the good ideas, who's always smart and clever and witty and so on. And there were a lot of personality similarities between the idiot arguing geocentrism and the Pope. So Galileo, he wasn't an idiot, he was pushing buttons. He was almost certainly doing it on purpose. But, well, he did it, and the reaction was pretty severe for Galileo. The Roman Catholic Church excommunicated him for suspicion of heresy, since he kept insisting that the Earth's not the center of the universe. And the church told Galileo, stop talking about this, stop telling everybody about this, just drop it, let it go. And Galileo said, okay, and then immediately went right back to doing it. So for insisting that, that our universe or solar system is heliocentric, not geocentric, well, the church excommunicated him and put him under house arrest until he died. The last decade or so of Galileo's life was miserable. Living under house arrest, cut off from everybody he knew. Pretty awful for doing science, although doing science in admittedly a pretty obnoxious way. Now, luckily for us, in the year 2000, Pope John Paul II did officially apologize to Galileo, so I felt good about that, but maybe a little late. But Galileo gave us our first real evidence and starts really turning the tide towards a heliocentric idea. Now, we're backing up in time a little bit. Tycho Brahe is one of my all-time favorites, and he's a contemporary, not coming after. He was a contemporary of Galileo. But Tycho Brahe, first of all, disproved the existence of these celestial spheres because he could observe that things were actually crossing those orbits, and how could they cross orbits if those spheres are real physical things? He tried to combine what he saw as the good parts of Copernicus with geocentrism, but nobody cares. We don't care about Tycho Brahe's ideas because what really matters about Tycho Brahe is the way that he kept data. He collected tons and tons and tons and tons and tons of data, which shortly thereafter, after he died actually, that data was put to use by his assistant Johannes Kepler, who did some great things with it, which we're going to talk about in class really, really soon. I'll see you there.